Okay, here we are with our first video on trigonometry, and what we're going to look at today is something called the tangent ratio, the tan ratio. What I've written down here are the key ideas from last day, and you might want to pause the video and write these down, but to review what they are is angles of a right triangle related to the ratio of the sides. So what we discovered is it doesn't matter how big a triangle is, it matters what ratio the sides are in. We also learned something really straightforward but really important in that smaller angles are opposite smaller sides and larger angles are opposite larger sides. So I've drawn two right triangles. And I've kept the horizontal side of the triangle the same. But what I have done is I've changed the vertical dimension. So on the triangle on the right, what I've done is I've made the vertical side, the side opposite angle A, twice as big. And what we automatically notice is, well, angle A gets bigger. So if we made the side opposite angle A twice as big as the side in the right triangle is the one on the left triangle, then automatically we see that the angle gets bigger. But here's something really important. But the angle does not get bigger in proportion. So the angle does not get bigger in proportion. And by that, I mean if we knew how big angle A was on the left-hand side, angle A on the right-hand side is not twice as big. So this is really, really important. And if you're not sure, simply sketch these, measure these, and I guarantee you this will not, the one on the right will not be twice as big as the one on the left. If it were that easy, we wouldn't need trigonometry. So that's this idea of that, well, we need a way of answering a question like this. And in order to answer a question like this, we need trigonometry. And in order to answer these questions that we're looking at today, we need a special trig ratio. And the trig ratio is the tangent ratio. Now, as we go through the unit, we're going to learn two other ratios. And if you look on my graphing calculator right here, you will see an SIN button, a COS button, and a TAN button. Those are the buttons of trigonometry. Those are the ones we're going to push tons and tons and tons of time. SIN stands for sine ratio, COS cosine ratio, and TAN tangent ratio, and that's the one we're going to look at today. In order to press each one of those buttons, you have to determine the relationship of the sides you are looking at. They all represent a different relationship with respect to sides of a triangle, because the relationship between the sides of the triangle is what affects the angle, and that's what we've looked at. So let's look at our first one today then. I'm going to draw my right triangle, and I'm going to call this angle A. Now, in a right triangle, we have three sides, of course. Now, the one that's most easily identified is the hypotenuse. The hypotenuse is always opposite the right angle. One of the issues that comes up is, well, how do we identify the two other sides then? Well, you identify the two other sides by our language opposite and adjacent. We could use the language vertical and horizontal, but those are set in stone, just like the hypotenuse. Opposite and adjacent are relative words, and by relative I mean it depends on which angle you're talking about. So relative to angle A, this side over here, which is the vertical side in my picture, is opposite angle A. And relative to angle B, the other side of the triangle, remember they're called legs, but the question would be, well, which leg are you talking about? Relative to angle A, this is the adjacent side. So these are going to be the words, this is going to be the language you're going to use in this unit. So it's going to be really important to understand this idea of opposite and adjacent. And in your head, however you wrap your head around it. So opposite, across from, adjacent, beside, touching, things like that. And here is this particular ratio. So the tangent ratio, by definition, this is what it is. The tangent ratio of a particular angle, and I'll just call it A for now, is equal to the length of the side opposite to angle A. So this, I'm calling my angle A, compared to the length of the side adjacent to angle A. And again, what happens is if we change one of these sides, angle A changes. That's what we looked at last day. That's what happens. And what this relationship formula, if you want to think about it that way, is it will allow us to answer questions about particular triangles. Because last day we learned that trigonometry is angles are based on similar triangles. So if we know a particular relationship, we can go ahead and solve many, many, many triangle questions. So here's our shorthand tan ratio. This is the one that'll get stuck in your head. This is the one that's given on your provincial exam, and this is the one that's on your blue sheet right now. So the tangent of an angle is equal to the ratio of the side opposite that particular angle divided by the ratio, divided by the length of the side adjacent to that particular angle. Now I want to highlight in this, again, this formula, if you want to think about it that way, there are 4 parts to it. The angle part, the side opposite the angle, the side adjacent to the angle, and finally, this thing. Now, for right now, I want us to think about this as a button on your calculator, a button that does something. So this does not change. We actually press it. It's the yellow highlighted stuff that can change depending on the particular question. So let's go through 3 examples, and these are the only 3 questions I can ask you because there's only 3 things highlighted. So let's do example number 1. Example number 1. You are given this triangle. So here's our triangle. And we have angle A, and here's the given information. Angle A is 27 degrees. The side adjacent to angle A is 5 units, and we want to know the side opposite. Pythagoras won't solve this because we only have one side. But we do know something about angle x right now, or sorry, side x. We do know something about side x. We do know that side x is less than 5. And you should be able to tell me why that is so. But let's go ahead and answer the question. So I know it's less than 5. So then the question is, well, what exactly is it? And we need our calculator to do this, and we need to press a button on our calculator to do this. Eventually the problem is which button. In order to help us with that question today and down the road, I have something called WIC. Now, WIC is showing your work. A lot of the stuff you're going to do in this unit, you're pressing buttons on a calculator, and but what WIC does is it shows your work. And here's what it stands for. W stands for what, I stands for I, and K stands for know. What I know, or what I want to know. And by doing this, hopefully it points you to the right ratio, or want to know. So here's what I mean. What I know. Well, what I know is I know the measure of angle A is 27 degrees. And what I know is I know the side adjacent to angle A. It's 5. And what I want to know is the side opposite. And hopefully what you see in writing down what I know is you see that opposite and adjacent. And by definition, that's our tangent ratio. So what I know points you to the right place. And then after that, it's a matter of just going ahead and writing the formula and then understanding that there are three things that vary and that we're always given two of them. So the three things that can vary in this ratio are A, opposite, and adjacent. Remember, the tangent's a button on your calculator that we're going to press. It's going to do something. So let's plug in what we know. Well, I know that A is 27 degrees. I know that opposite is X, and I know that adjacent is 5. So here I have a formula, and in that formula there's only one unknown. There's only the X. Because remember, that tangent word is a button on our calculator that does something. So the thing I'm going to suggest right now, we're going to talk more about this in class, is I'm going to suggest we get rid of that tan right now. And we can do that by pressing the button on our calculator. Remember, it's a function. It does something. So if I go to my calculator and I press the tan button and I press if I press 27, and I hit enter, my calculator is going to spit out that ugly number. And all I'm going to write down is 0.5095. Intermediate calculations to 1 decimal place. I'm going to talk about this more in class, the start of class. But for right now, I'm just going to push the button. And when I push the button, I get a number. And now that I get a number, I can just go ahead and solve an equation. So I'm going to multiply both sides by 5 to clear the denominator. And when I do that, I end up with x is equal to 2.546. And I said earlier that I know x is going to be less than 5. I asked you to think why, and in fact it is. So to me, my answer makes sense. And if I were going to round this, because this is my final answer, I'm going to round it to 1 decimal place, 2.5. Now, if you've done that calculation on your calculator and you haven't got when you press tan 27, if you didn't get 0.5095, you have to go to your calculator. If you have a graphing calculator, you're going to press the mode function, and the third line down, you're going to see radian and degree. In grade 10, we want our calculator in degree mode. So you need to scroll down and go over, use the right arrow until degree is flashing, hit enter, and then you will be good to go. And if you ever get in a screen on your graphing calculator and you want to get out of it, you always press second mode. If you have a scientific calculator, then what you're going to have to do is there should be a DRG button on your calculator. Okay, so we've used this special trig ratio. And by special, I mean this is the ratio you use when you have the side opposite and the side adjacent. If you have the hypotenuse, you cannot use the tan ratio because that is not a part of our formula. So let's look at a second example. Example number 2. Or example number 3, actually. So here's my picture. I have this right triangle, not to scale, but it's not bad. I know that I'm going to call this, we're going to call it angle B this time. It really doesn't matter what you call it. I know that angle B is equal to 62 degrees. I know the side opposite angle B is 10, and I want to know the side adjacent to angle B. So again, what I would like to see is what I know. Well, what I know is I know the measure of angle B. I know the side opposite angle B, and I want to know the side adjacent to angle B. And what I see right there is opposite and adjacent, so that points me to the tangent ratio. And the tangent of angle B, remember the angle is just a name, is equal to the ratio of the side opposite angle B to the side adjacent to angle B. And now it's just a matter of plugging the things in the right place and using my formula. So the tangent of 62 is equal to the side opposite to the side adjacent. So there's our equation that we have to solve. This is a little trickier equation because the unknown is on the bottom. But the first thing I can do is I can get rid of tan 62, because the tangent of 62, the tangent ratio of 62 degrees is just a number that my calculator will give me when I press the buttons. So I'm going to round this to 4 decimal places. The tangent ratio of 62 degrees is equal to 1.8807. So 1.8807 is equal to 10 over x. And now we just go ahead and we solve this equation. And in order to solve this equation, we can clear the denominator, which means multiply both sides by x, and then solve the remaining. But I'll give you a little shortcut right now. And again, we're going to talk about this in class as well. But a little shortcut for right now is what eventually happens is you just interchange that number to the left with the x on the bottom. And again, we will look at the algebra behind this in class. But what we end up with is x is equal to 10 divided by 1.8807, and that equals 5.3. And now it asks you again, does 5.3 make sense? And the answer hopefully should be yes, because the side opposite 62 is 10. That's a big angle. The other angle that we aren't told, but we can easily figure out, is smaller than 62. So therefore, the side opposite a smaller angle should be smaller. And in fact, it is. Okay, so an unknown on the bottom. Unknown can be on top, unknown can be on the bottom. The only other example, the only other thing we have to worry about is when the unknown is an angle. So if I drew this picture right here, example number 4, if we drew this picture, again, not to scale, and my side is 12 and my side is 17, and I want to figure out angle A. Well, again, I could use Pythagoras to find the other side, but I can't use Pythagoras to know what to do. But what I can do is, in getting myself started, I can write down what I know. Well, relative to angle A, 12 is opposite. And relative to angle A, 17 is adjacent. And I want to know angle A. And again, in writing down what I know, it has pointed me to one of the 3 ratios that I need, and today, of course, it's the tangent ratio. So given that I know to use the tangent ratio based on the information given, here's what the tangent ratio is. And then what I'm going to do is I'm going to plug in all the things I know. Well, I don't know A, I know opposite, I know adjacent. So here's where we get to in the third kind of problem that pops up. And in order, this actually turns out to be the simplest one to answer. The other ones involved a bit of algebra, and if you're not super strong algebraically, that's potentially a problem. But finding an angle is the easiest because you have to use your calculator. You just have to know how to use it. And in order to figure out an angle, what you're going to have to do is, on your calculator, if you look above the tan button, you will see tan minus 1. In order to determine an angle, you're always going to, I'll call it, undo the tangent. So in this particular example right here, what we're going to do is we're going to press second tan, and then we are going to put the 12 divided by 17, and when we hit enter, our calculator spits out 35.2175. So if I wrote that down in our notes, in order to find an angle, you're always going to use the undo button. And the undo button looks like this. So whether it's tan to the -1, sine to the -1, or cos to the -1, these are the buttons you press when you want to find an angle. And all our calculator asks us to do then is to punch in what we have. And what our calculator spits out is the angle. So what this says is, if we're given this triangle where the side opposite angle A is equal to 12, and the side adjacent angle A is equal to 17, that angle A is going to equal 35 degrees. So here's these three basic ratios. If I gave you a different triangle to the one we just did, and if I said the side opposite angle A was 13 and the side adjacent to angle A was still 17, well, in your head you know that that the angle A is going to be bigger than the one example we just did. And what we would now know is, hey, given that I have opposite and adjacent, I can simply push buttons on my calculator and my calculator will give me the answer. So here are our key ideas today, and we are going to expand on these at the start of class. The key ideas in today are, in order to use the tangent ratio to find sides and angles of a triangle, here's what's important to do. It's important to draw and label your right triangle. Now, I've done that for you today, but it's going to be important for you guys to do it as well, for yourself. It's important to write down what I know. Now, what I know today is always going to take us to the tangent ratio. And then, given that you've decided on a particular ratio, what you are going to do is you are going to put the numbers into the appropriate place and solve an equation. Now, the solving should be the easy part, but it's the appropriate place. And the appropriate place then turns into, well, is it the angle? Or is it the opposite? Or is it the adjacent? And as long as you put it in the right place, algebra or arithmetic are the only things that are going to cause you troubles.